Aloha everyone, we are your presenters today. My name is Pevelini, I'm from New Zealand.
And my name is Leilani, and I'm also from New Zealand.
We will be presenting on Chapter 8, which is about information processing theory. So we'll be focusing on the 4 sections in the textbook or of this chapter. But this chapter is important because the information processing decisions you make affect when you learn, how much you learn, how well you learn, and of course, whether you learn at all.
And so throughout the presentation, we do have 4 tasks for you guys to complete. So when we do get to these sections, feel free to pause the video to complete the tasks. These tasks are here to help you think about how you personally process information and how you can use your understanding, knowledge, and cognitive skills to perform the different tasks. We also have a Kahoot quiz, which we'll have in the comments section below for you guys to complete, and this is based on our presentation and also what is in the textbook. All right, so feel free to review the Kahoot and also participate in the tasks. So going straight into our first section, the information processing view of learning. And basically this is talking about how humans attend to recognize, transform, store, and retrieve information, or quite simply, how we process information. And so this theory rests upon a set of assumptions, and the textbook highlights 3 of these, and we've got the 3 on the slide for you. The first one is information is processed in steps or stages. And so basically, throughout our lifetime, we will go through these different stages. And it's kind of easier to think of as we grow older or get older, we will go through these different learning stages. And in each stage, we're able to process information differently, hopefully a little bit better as we grow up. And as the textbook says, at an early processing stage, human beings encode information in somewhat superficial ways. And then as we go into later stages, we're seeing more meaningful ways of how we process things. And I think we can all just reflect about our own personal experiences, think about how we were even back in primary, and then think of how we are now and how we probably processed information differently back then to how we process information now. The second assumption we've written is we're limited, but we're also limitless. And so the textbook actually talks about how there are limits on how much information we can process within each stage or step, as we talked about. And it means that we just need to be learning quite gradually and over time. However, over the whole course of our life, we're actually quite limitless in the overall capacity of information that we can take in. So it's really amazing that although we can only learn so much in a particular stage over the course of our life, we can actually take in an unlimited amount of information. And then thirdly, the human information processing system is interactive. And what this is referring to is, you know, we're seeing things every day, every second, and we're taking in this information. This in turn affects how we think, how we see and perceive the world. And then it just keeps revolving around in the cycle of we're seeing things, we're taking it in, we're learning, and that is changing how we're then again seeing things differently. All right, so that's that first section. This brings us to our first task for you guys, and so feel free to pause the video now. Basically what you need to do is just to fill in the blanks of the table below, which is just counting how many numbers you can spot. So for number 1, we've got 21s. Try not to go cross-eyed as you calculate the totals for each number, but this is just to test how you guys process and think. All right.
Okay, so section 2. So this is the model of information processing. So there are various components and processes that make up the multi-store model of information processing. So this here is the model, which is also found in a textbook. So just on the top there, the control processes are an important aspect of the information processing system for two reasons. First, they determine the quantity and the quality of information that the learner stores in and retrieves from memory. And second, it is the learner who decides whether, when, and how to employ them. Okay, so we're going to focus on the 3 memory stores. So the first one there is sensory register, which is also known as sensory memory, which means not consciously controlled. It allows individuals to retain impressions of sensory information after the original stimulus has ceased. And so an example of this is you see something for an instant, and then someone asks you to recall one detail. The next one is a short-term store, also known as short-term memory. So it doesn't last for a very brief time, but an example of that is you look up a telephone number and rehearse it long enough to dial it. And then we have the long-term memory, or known as the long-term store, and that holds an indefinitely large amount of information and can last for a very long time. So an example of that would be you remember the house where you lived when you were like 7 years old or when you were young. So just to share brief information on sensory register. And so it takes in sensory information through your 5 senses: sight, hearing, smell, taste, and touch. And it holds it for no more than a few seconds. So there are 2 main areas of sensory register, which is recognition. And so the important point to remember is that recognition and meaningful processing of information are most effective when we make use of all available sources of information. And also says there that elementary students need more structured learning tasks than middle school or high school students. And so because of the limited store of knowledge and long-term memory, younger students should be provided with clear, complete, explicit directions and learning materials. Doing so will ensure that students are not left confused after instructions, but will find it much easier to recall later things they understood rather than they misunderstood. And then the second one is attention. And so that's focusing on a portion of currently available information. So in other words, we choose what we will see or hear by using our prior knowledge and experiences to anticipate the nature of incoming information. So pretty much we decide for ourselves what things we would like to focus on, what to remember, and what to forget. And then I also just have a little video there from YouTube. It's a nice quick video, but it focuses on our selective attention. So feel free to watch that. We have here the short-term memory. And so short-term memory is also referred to as working memory because of how it is actively processing information. Like for example, how to solve a math problem or recalling a scientific formula. So that all takes place in working memory. And so between short-term and long-term memory, it's focusing on encoding, organizing, and retrieving information. One important way of helping us transition our memories from short-term to long-term is rehearsal. And so rehearsal is the role of repetition in the retention of the memories. So I've got 2 types of rehearsal. I've got one maintenance rehearsal, which holds information for immediate use. And so it could be either mental or verbal repetition. And then also it's not effective in the long-term memory storage. And then the second one is the elaborative rehearsal, and that's use stored information to aid learning. So using information stored in long-term memory to add details to new information. This can be by organizing material that reduces the number of chunks, provides recall cues, and then also meaningful learning occurs when organized material is associated with stored knowledge. Okay, so we have here our long-term memory. And so this here is the permanent storehouse of unlimited capacity. And so I've searched this on the internet and I found 3 types of long-term memory. So one is semantic memory, which are memories of facts and figures. So an example of this is knowing what a bicycle is, being able to name the parts of a bike and explain their function. The second is procedural memory, which is memories how to perform an operation. So an example of this will be able to ride a bike or tie shoelaces. And then the last one is episodic memory, and these are memories of specific events and personal experiences. So an example of this will be the first time you rode a bike unaided. And so the memories contain not only the specific details of the event, but the context and emotions of the experience. And then also just on the bottom there, information and long-term memory are organized as schemata. And so it pretty much with the example I've given there, that dogs bark and birds fly. And so it gives us expectations about objects and events. And then also when our schemata is well performed and a specific event is consistent with our expectation, and then our, from there, our comprehension occurs. Cool. So this one here is why we forget. And so forgetting is the ability, often temporary but possibly permanent, to retrieve previously learned information. And so these are the following reasons why we tend to forget our memories. So the first one, it's because it wasn't learned in the first place. That comes under inadequate consolidation. Second is non-meaningful learning. So the existing knowledge schemes wasn't taught in a meaningful way. The third one is few opportunities for retrieval. So probably a lot of us kind of experience this one, which is we don't want to hear it. The next one is interference from other materials. So we pretty much cope with a constant stream of learning material. And then the last one is a lack of retrieval cues. And so that's any information such as a word, phrase, image, sound, etc. So that is like associated with the learnt material. Cool. So for task 2, how good is your memory? So for this task, I would want you to pause the video, and we'll be testing your attention and memory. So you have 20 seconds to analyze and remember this picture and try and get as much information out of this picture and answer the questions on the next slide. So the questions is, what type of boat is shown floating in the lake? And then what color are the dog spots? So if you don't remember, you can go back and have a look to see if you got the right answer. But yes, I hope you got the right answer.
Cool. And so we're going into the third section here, which is metacognition. And the discussion up to this point has really focused on really how people attend to, encode, store, and retrieve information. But now going into this section, we're now looking into another level of learning, which explores the idea of how what we know about our own thought processes affects how we learn and solve problems. So it's really thinking about how we think, learning about how we learn, and figuring out a way to use how we know about ourselves to interact with others or other information specifically. And so this phrase metacognition was first introduced by a psychologist named John Flavel, and he used it to help explain why different ages dealt with learning tasks in different ways. And so he had a study in which he gave students of different ages a specific task. And, you know, for example, he would give a 7-year-old a task to remember pairs of nouns, and there would be a less effective technique of doing this, which is probably just like repeating those words, those nouns. And then there's a more effective technique, which might be imagining the members of each pair doing something together. So interacting those nouns together. And so for those 7-year-olds, it was quite a difficult task, and they would more or less use the less effective technique to accomplish it. And then he would give that task, same task, to a 10-year-old group, and they would be able to do the task using the more effective technique. And so he kind of examined that difference of why a 7-year-old might do it differently compared to a 10-year-old, and then in turn how a 10-year-old would do it differently to a 20-year-old, for example. And with this, he recognized that as we grow older and have different experiences, we're able to learn different problem-solving methods, and we're able to, I guess, figure out different strategic learning ideas about how we process information and then how we can go at a task. And so that's basically why we've been giving these different tasks throughout the presentation as well, because although it's one task, each of us might be going at it in a different angle, all right? And so to help us better understand what really metacognition is, we can break it down. And on the slide, we've got cognition, which is used to describe the ways information is processed, or basically attended to, recognized, encoded, stored in memory for however amount of time, and then how we retrieve it from storage and use it. But then when we're looking at metacognition, like I said, it's referring to two things. What we actually know about ourselves, what we know about how we think, and how we're able to guide and control our cognitive processes. And so for ourselves, when we're thinking about metacognition, you might hear people saying that they're a visual learner. And so being a visual learner, you might have preference to using highlighters or arrows or diagrams in your notes because you feel that you're going to remember it easier that way. Or you might recognize that you're pretty bad at remembering people's names. And so you find it easier to remember by writing their name down. And by writing it down, that helps you lock it into your memory. Or you might start a puzzle and you've recognized that what helps you solve the puzzle quick is you're going to figure out all the edges first, you know? These are all different ways of us exploring our own metacognitive abilities because we're examining how we are learning, how we're taking in information, and how we're going to use it to help guide our own cognitive processes. And so as we grow older, this skill actually develops. And on the slide, I've just put 2 of these examples, but in the actual textbook, if you want to check it out, there are a whole page worth of examples of how this skill develops from a kindergarten age all the way into a grown adult, and how we're constantly learning about ourselves. We're constantly learning about how we think and how we can use these experiences to help develop our knowledge of taking and going at tasks. And so for that first trend, it says many kindergarten and first grade children try to remember a set of objects by using such techniques as naming them, grouping them in categories, arranging them in alphabetical order, or creating a story about them. And so they do that, but few of them can explain why these techniques work. So they don't really have an understanding of their metacognition. They're just doing it. But then when we look at 4th and 5th graders, they do understand these tactics and recall. So they're not just doing it to do it, they're doing it because they recognize that's what's going to help them learn easier. And then the second example is, when given multiple opportunities to study and recall a lengthy set of pictures, 6-year-olds choose to study pictures that they had previously seen and recalled, as well as ones they hadn't. 3rd graders, by contrast, focus on previously unseen pictures. And so this one kind of explores the different strategies of how different ages might go at a task. How if we're studying a group of pictures, for example, for a younger group, they're going to look at everything. But as you get older, we're recognizing maybe if you know this already, we don't need to study this as much. Let's just study the things that we don't know about. This is all thinking about our metacognition. And again, this is something that just adjusts and changes gradually with experience. So what does this mean for you? Well, we really need to be more aware about our own personal metacognitive, cues, and think about how we study, what best works for us, and be strategic with that approach. Be strategic of how we take things in. For example, me going into this presentation, I hate reading the textbook, so it's a bit difficult for me to do that. But if I kind of look at the different graphs and things, that definitely helps me. And so you guys might have your own study techniques or different things that might help you. But just know that the greater personal metacognitive awareness you have brings greater results. You're able to soak in information more efficiently. And then as a teacher, or as you're trying to help others around you, we need to be able to recognize metacognitive skills for others. And then we can give them tasks that are more fitting for them to help them learn better. And so we can self-analyze and look at the different learning styles or ways that help us focus better or comprehend better. And this helps us really achieve in school and kind of in life, because we're always learning. We're always learning, not only in a school environment, but as we perceive the world and take on the world, we're always taking in information. So as we're more aware of how we learn, we can monitor ourselves and be more efficient so that we're able to really take things in. And so on this slide, we've just got a few suggestions of personal analysis for you, of whether you're a visual learner, auditory learner, or if you choose to skim subheadings or things like that. So feel free to self-analyze, and I highly recommend that, because it really does improve the way that you're able to really soak in the information and use it. And so our third task is a Sudoku, And hopefully you're familiar with this. It is basically a task where you need to fill all the empty cells with a number so that all the columns and the rows in each region contain the numbers 1 to 9 only once. So feel free to pause the video now so you can complete that task.
Cool. So our last section of our presentation is technology as an information processing tool. And so technology can help students improve how much and how well they learn different subjects, different ways on how to import technology in a classroom environment. So feel free to go into our textbook and to read the section about technology, as there's so many options on how you can apply it in a classroom environment. And so I have here advantages and disadvantages when using a technology tool. And so the thing that stood out to me when it came to reading the advantages of using technology is it helps to solve problems for students, and also it organize and mentally represent ideas. So there are different options that's listed there. And then also for disadvantages, the one that stood out to me was that students can easily become overloaded when using technology, or they could be distracted. And so the solutions for the disadvantages for teachers is that they should teach students how to be disciplined and purposeful users of technology, and to choose hypermedia and programs that have the fewer features. And so an example of using technology tool is my nephew. He is 8 years old. He's in primary school in New Zealand. And so at his age, it's compulsory for them to have laptops, which they take home and take to school. And so that kind of motivates him to do homework. And so there's websites on there that are blocked for him to have access to, which is a good idea. But I feel that technology helps younger generation to learn and to be motivated also in the classroom. And so this here is our last task. So pause the video and set a 10-second timer to complete this maze by starting at the pink line. Okay, and so that is our presentation. If you haven't done the Kahoot, we encourage you to complete the Kahoot and also read our handout. And yes, mahalo, thank you for watching.
Thank you.